So, if we are looking at Glencoe Accelerated Math, Lesson 6-4 on finding the percent of change, and we're on page 270, and that said we're going to solve things a little bit differently so that we can use our proportion instead of using an equation. Here's how we're going to set up that proportion. We're going to have the change over the original equaling some percent out of 100. By doing that, when we put that percent up there out of 100, that way we don't have to worry about moving decimal points and remembering which way our decimal point moves. So, if we look at it in the book, this part stays the same, but that division is equal to, that division is going to be a decimal, and then we have to move the decimal place. Okay? For the most part, I think we liked the proportion better. Am I remembering correctly? Yeah? Okay. So that's how I'm going to show this to you. Both ways work just fine. My recommendation, pick one, stick with it. Alright? So, if I look at example 1, I can have several pieces of information. I can be given the original, or the O. I can be given a new quantity, or an N. I can be given the change, or the C. Or I can be given the percentage. Alright? There's 4 pieces of information. I need 2 of the 3 for my proportion. So someone please read for us example 1 on page 270. Nice and loud so we can all hear it. Go ahead.
Find the percent change from 60 degrees Fahrenheit to 84 Fahrenheit. Then state whether the percent of change is an increase or a decrease.
Okay, so we have to find the percent of change, and then we have to determine if that is an increase or a decrease from what we had previously. Do I know my original temperature in this problem? Does it tell me what temperature we started at? Yes. What is it? 60 degrees Fahrenheit. Okay. Am I given a new temperature? Am I told where we stop at? Yes? What is it?
It's 84 degrees.
84 degrees Fahrenheit. Sounds kind of like our weather even though it's January, right? And then we drop 30 degrees and we do the same thing. Alright? But, sounds kind of like our weather here in South Carolina. Am I given the change? No. Can I find the change?
Yes.
Yeah. Am I given a percentage?
No.
No. What am I trying to solve for the change, or am I trying to solve for the percentage? Okay. Is my answer, look back at the problem, is the answer looking for a number of degree change, or is it looking for a percent of change? It's looking for a percent of change. Okay, so this, I'm going to call X because we don't know that. What is the change in my temperatures? How much did the temperature change in that day? Yes, sir?
24 degrees.
24 degrees. Okay? Based on this information, can I plug that into my proportion? Yeah, alright. What's my numerator for as my change? 24. What's my original amount? 60. My percent is
6.
and percent is always out of 100. before we do anything else, are there any questions about how we got the information that we have? Okay. All right. What do I do from here? Go ahead. Cross multiply. When I cross multiply, what does my first line of work look like?
24 times 100, which equals 60 times x.
Thank you. 24 times 100 is 2400. 60 times x is 60x. Then what do I do? Yes, sir? I divide each side by 60. Why am I dividing by 60? To get the variable by itself. Okay? So the number attached to my variable, that's what we divide by. My 60s will cancel. 2,400 divided by 60 is, go ahead. 40. Now, my problem, my variable, I'm looking for a percent of change, correct? So can I, on my answer line, just write 40? No, because I'm looking for a percent. So how do I write this as my final answer? Yes, sir?
40%, sorry.
40%? Okay. Now the second part said, is it an increase or is it a decrease?
Decrease.
Hold on. If I go, my original was 60, my new is 84. Am I going up or am I going down? I'm going up. I'm going from 60 to 84.
Oh.
Okay? If I'm start at 60 and I'm going to 84, that is an increase. So I can do that by drawing an up arrow or I can write increase. What questions do we have? What questions do we have? We don't have any? No? Okay. What if... What? Okay. What if I was looking for a percent of error? What do you think would change if I was looking for a percent of error instead of a percent of change? Because is an error a change? Yeah. That says how far off you were. Okay. If you are estimating in a couple years the amount of money that you will spend on a car, let's say that your parents gave you a budget, okay? And they said you have this amount of money to find a new car because you are a teenager and you need a car, and so therefore you have this budget. Okay? What? For the sake of this argument, let's say you're looking for a car. Okay? All right. If that... So you're estimating that you're going to spend that amount of money. Okay? In all reality, are you going to be able to buy the vehicle for exactly that amount of money?
Nope.
No. No. Because there's going to be taxes and you're going to try to get the price lower and, you know, you're going to... Well, and you're going to have to pay for insurance and things like that. So, and yes, you have to pay taxes on cars. You will have a vehicle tax that you pay every year so that your license plate tags stay up to date, and you have to pay a sales tax on your car because you are purchasing an item. So there's going to be an error. There's going to be a difference between the amount that you actually pay and your estimate, which is your budget. Okay? So in the context of this, what would my change become? Our options are Estimate, actual, or error?
Error.
Right, the change is going to be my error. Because the error is the difference between what I actually spent and what I was expecting to spend. Okay, so that becomes my error. The change is my error. Would the new be the actual or the estimate?
The estimate.
Right, the new is going to be the estimate. Which means the original is also what? Starts with an A. The actual. Okay? Because we want the amount of the percent of error to be based on what is actually true, correct? Right. So because the percent of error is based on what's actually happening, that means that that is our original, which we put into our proportion. The estimate and the new don't go in there. So let's look at an example. Someone please read example 3. Alright, nice and loud so we can all hear it. Go ahead.
Alyssa estimates that her school auditorium has 660 seats. It actually has 750 seats. What is the percent error of her estimate?
Okay. So, we need to find the percent of error comparing a student's estimate to the number of seats in an auditorium compared to what's actually there. Am I given my original / actual? Yeah, what is it? 750. Am I given my new or an estimate?
Yes.
Yes, which is? Am I given my change or the error? No, can I find it? Yeah, so what is my change or my error? What? 90. Am I given my percent error?
Yes.
No, but can I find it? Okay. So, this is what we've got. Can we use the same formula? Yeah. Are we going to? Yeah. So, my change is what?
90.
90. What is my actual / original?
750.
750. That equals some percent out of 100. What do I do?
90 times 100. 9,000.
Okay. I don't know what to do with that.
Oh. Now you have to do 750 times x, which is 750x.
Okay. Thank you. Now, whether I simplify one side of my equal sign and then the other, or if I go line by line, do I get to the same spot? I get to the same place either way. In both options, I end up with 9,000 equals 750x. But here's what I'm going to ask you to do. I'm going to ask you to go one line at a time. Right now, not a huge deal. However, what we do here is we're setting up an equation. And when we solve equations, we have to go line by line. You can't solve, you can't work on one side and then come back and do the other side. It doesn't work like that. Okay? So let's get into the habit of going line by line by line by line. Okay? What do I do with 9,000 equals 750x? Go ahead.
You divide 9,000 by 750 equals 1.2. And then, yeah, you do 750 divided by x. You do it the same time.
Okay, so the 750x divided by 750, those cancel. I'm left with x. 9,000 divided by 750 was what?
1.2.
1.2. Okay. What did my problem ask me for?
This, wait. What is the percent? I'm asking it.
It wanted the error?
They wanted to.
It wanted the percent of error. My error is 90 seeds. The percent of error is 1.2%. So we have to make sure that we're putting our answer in the correct form. If it asks us for a percent, we have to put that percent sign. If it does not want a percent, don't give me a percent sign. Yes, sir.
Yes, my error is 12%.
Ooh. So the book says 12%. I was told 1.2. Somebody double check.
Oh, I did 900.
Oh, you did 900 instead of 9,000?
Wow.
Ooh, that's a bummer.
Come on, man.
Tough.
Because that adds in a decimal point that we shouldn't have, doesn't it? Okay. Shh. So, 512 equals x. How do I write my answer?
You put 12%.
12%. Do I have to add an increase or a decrease or anything like that?
No.
No. Because it's asking for an error. It doesn't matter if we were off, 90 seats higher or 90 seats lower. The error is an error. Error is how far from the actual amount we are. If we're looking for a percent of change, yeah, you need to tell me, is it an increase or a decrease? Questions? No questions? I have one for you. Does it matter what pieces of information I'm given here? Could, if I was given the original and I was given the percent of change, could I find the new amount? Yeah. What would I solve for? Because I don't see an n in my equation. Let's say I was given my original, I'm given my percent, I'm told to find the new. What would I solve for in my proportion? Yes, sir.
You would solve for n over.
Ooh, but see, I can't put an n here. That says change. But I can't. I'm given a number here.
Oh, that number over n.
If I have O equals 78, and C, the percent is 23%, can I find n? Can I get to n? I can. How do I get there? What am I solving for? Can I solve directly for n?
Oh, I know.
Can I solve for my change? Alright. Using these numbers, I have no idea what context it's going to be in. Does it really matter at this point? And we're going to say it was a 23% decrease. Okay. Hey guys. I don't know C. So I have my change over 78 equals 23 over 100. That gives me C times 100 equals 78 times 23. 100C. 78 times 23. Help me out, guys. 78 times 23.
1,794.
Please now.
Okay? I divide by 100. C is equal to 17.94. That's a decrease. Then to get to n, I'd have 78 minus 17.94. Double check me, is that right? That is right, because to get the 10 there, I need that to be 9. Okay. That's why I have you double check my mental math. So, that means that my new is 60.06. So yes, we absolutely can solve for that. 100%. We can absolutely do that. Okay? The difference is we were given different information. That means we need to find different things. Okay? You know how to solve a proportion. I'm not worried about that part. You know how to take a formula written as a proportion and plug things in. You know how to do that. What you're going to have to do is figure out what information you're given and make sure that it's used appropriately. All right, any last questions? Thank you very much.